Hi, in this video on the Raspberry Pi 1 with the binary counter controlled by the Raspberry Pi 2, I focus on the code and on timing, because last time I had this problem that I tried to fix, where I confused input state and reverse state. I fixed that as good as possible, but that does not solve, apparently, the fact that here with the LEDs, let me get them a little bit clearer inside. So this is 1, this is 2, and this is 3. And the main problems are, except for the code, that this first and the third LED do work. The second LED intermittently, and last time it mostly didn't work, and without any change or whatever in controlling it, it just started burning again. However, apart from that issue, is still the problem that it takes a long time before the digits are actually showing. And of course, the speed of showing depends for a bit on this. However, this is another reason why the bits are slowing down, because this is only the time that it counts up, and this is only the time it counts down. And whenever this is going on, this is not going on, and vice versa. At least that should it be. So when looking at this code, it's still the question, right, I have this running, I have this checked out, and when looking at the other one, these are of course 0 and 0, because if the input state is totally 0, it shouldn't run anyway. At least that is the intention. Input state is 1, then it shouldn't run. That's the intention, at least. But as said, that is totally apart from the reason, which I haven't found yet, why the counter has slowed down so much. So I intend to find that, and hopefully finally it's being solved, so I can move on to another experiment. Anyway, that's it for that is the focus for this video. While checking for timing, there are of course a few moments that timing is used, apart from the control code, which I showed earlier, lasting 20 seconds. Here there's a sleeping of 2 seconds, and this is the first sleeping, just checking for the input state. Then a repeat checking sleep for 2/100ths of a second, and you should be able to verify that because this is reading as 2 million, but it is actually 2 seconds. So 20,000 is a factor 100 less, which means in my thinking it's 200ths. However, this one is for this while, and this one is inside an if, and that is inside this if. Checking further, we have a similar situation in this if, and again 200ths. Looking further, there is no sleeping anymore. So the question is if this sleeping is responsible for the delay, and reasoning from this point of view, I doubt that. On the other hand, in the original code, this situation was for the manual switch, and I left that quite some time ago because I replaced the manual switch by the control for the from the RPi2. So I wonder what may happen if I remove this sleep. So let's go there, and let's go to the other sleep as well. No idea yet if it solves anything, but hey, if you don't test, you will never know. So it compiles fine as expected. Then let's see, that is ready to start. So here I start, and here I start, and let's see what happens. LED 1 is burning, and already that is taking too long, because it should burn for maybe 2 seconds. Okay, LED 2 is burning, which is an improvement because it already immediately starts burning as intended. So I can check. It's 1419. I should remove this code as well. It's no good at this time. And again, unfortunately, with the reverse, I expect it to go back to 1 and not wait till it's 3 or to hold the entire counting. So still something is going wrong, and considering the state of my code, it is not a code, but maybe something in the signaling, that the signal from the RPi2 is not dealt with correctly. See, and now we have digit 3. So let's see on the RPi1 side, this 14, 19, 27. This is 14, 20, 47. So that is 1 minute and 20 seconds later. Which is of course way too long. So putting this sleep behind as a command wasn't such a good idea. Well, it can be a good idea, but it doesn't bring the solution I want. And here 2007 comparing to the, oh, look at that, 2047 and 22.7. That's a heck of a long time. So let's abort this, and it just skips to digit 4. So for now the conclusion is that the code is okay now, but there's something in the, I suspect, in the signaling between the RPi2 and the RPi1. But I have to wait till this is done with. In the meantime, where does it read everything? That's it. I mean, it's done now. All the LEDs are off, all the LEDs, and here it reads the input state, here it reads the reverse state, and here the same is done. Although I notice that here GPIO 13 is read first and then GPIO 26, and here it is done vice versa. So would it matter if I reverse that? If I put this one in front of this? I might just try it. I doubt it, but who knows. So that's not correct. And no. Yes. Then again, that's input state. This is reverse state. I doubt that it is the solution, but let's just test it. and testing again. And this is 1. What I also have to keep in mind is the processing speed, because the RPi1 runs at, as far as I know, 750 MHz, while the RPi2 runs at 1 GHz. Except for that, very different CPUs, but that should not be any influence. But the clock speed may be of influence. And if that is of influence, I doubt that my problem is solvable. But testing. And once again, this takes way too much time. $14.27. And no, this is not the solution. So I have to look further into this. And I think that my thought of the speed of everything might just be the solution, in which case it may not be solvable, not simply anyway. So I think it's worthwhile to find out how that works. Considering everything so far and looking at the code again, GPIO 18 is the input state, GPIO 23 is the go and is actually the forward and reverse state. So when going, you actually say, okay, now you can count. So what I should do, and that is a mistake I guess I make, and bad programming, because I should have said here, let me go to this line, let me stop the program, is that GPI 18 is actually count or stop. While this one is actually forward or reverse counting. So when it stops, it does stop counting at all. So the pause I've been noticing is here just stopping to count. And what happens is that it counts for 20 seconds and then it stops counting for 20 seconds. And if either of those is simply happening in the period that that it switches from forward to reverse, you can wait a long time and never see it count reverse. That's one thing. On the other hand, let me it's nasty when you can't see your comments. Now it's saved. On the other hand, that still does not explain why the counting is very slow. So those are two things you'll have to realize before solving this. And with this in mind, I can leave this to rest, because that explains why things are resting, not doing anything. Although it does do anything, it doesn't, because when you think it does do anything, it just doesn't count, because this is 20 seconds of not counting. But during this period, it should either reverse or go forward. And there something goes not according to plan, which is not in this part of the code. Let me, come on, yes, but that is truly in this part of the code, and for that I have to dig deeper into it. But for now, thoughts are set straight, which is which, and once again, if you count, by all means do comment on your own code, because as it happened in the past and now, without commenting you forget what you do and you easily read your own code wrong. Anyway, that's it for now. Some reasoning, some trying, experimenting, and thanks for watching. To be continued.